Imagine a 441-foot cargo ship sliding into San Francisco Bay, built in less than 5 days, by workers who had never even touched a ship before. This is not a dream. This is the story of the SS Robert E. Peary and the revolution it sparked in American industry. November 12, 1942, Richmond, California. A cargo vessel, 441 feet long and weighing over 28 million pounds, stood poised to slide into San Francisco Bay through the gates of Permanente Metals Corporation, Yard No. 2. The SS Robert E. Peary had been assembled in just 4 days, 15 hours, and 29 minutes. In traditional shipyards, master builders would spend 6 to 8 months constructing vessels of similar size. Yet here, before a stunned audience, a complete Liberty ship was ready for service. Over 1,000 workers stepped back from the hull, not seasoned shipwrights, not experienced maritime craftsmen, but secretaries, farmers, housewives, and laborers who had learned welding techniques only weeks earlier. The air was thick with anticipation. Journalists, officials, and competing shipyard owners crowded the docks, unsure whether they would witness a triumph or a catastrophe. The mathematics of Allied victory were being written not in battle strategies, but in production statistics. This ship, this seemingly impossible creation, was a testament to human ingenuity and industrial audacity. It marked the beginning of a transformation that would echo far beyond Richmond, challenging centuries of maritime tradition. The story began over 2 years earlier, on December 27, 1940, when Henry J. Kaiser, a 58-year-old construction magnate who had never built a ship, signed his first contract with the United States Maritime Commission. Kaiser had spent his career moving earth and pouring concrete for massive dam projects across the American West. Now, he promised to deliver 30 cargo vessels for the British government within 2 years. Traditional shipbuilders dismissed him as naive, perhaps reckless. The Todd Bath Iron Works, one of America's oldest shipyards, agreed to partner with him, assuming their expertise would guide the venture. What none realized was that Kaiser's lack of experience in shipbuilding would become his greatest advantage. Among the spectators was William Francis Gibbs, America's most respected naval architect, whose firm had drafted the Liberty ship plans based on British designs. Gibbs had designed more ships than Kaiser had probably seen in his lifetime. Yet here he stood, watching a project unfold that would defy conventional wisdom. The revolutionary approach began in New York planning offices, where Kaiser and his engineers studied traditional shipbuilding methods. They realized immediately that conventional procedures could not meet wartime demands. Kaiser's chief engineer, Clay Bedford, had recently visited a Ford Motor Company assembly line in Detroit. Watching workers install components on moving automobile chassis sparked a radical idea: why not build ships the same way? When Kaiser proposed eliminating riveting in favor of electric arc welding, seasoned maritime experts scoffed. Rivets had held ships together for centuries. Welding, at this scale, was untested. Yet necessity, driven by German U-boats sinking Allied shipping at a staggering pace, left little choice. The Richmond Yard was born on mudflats in early 1941, designed not like a traditional shipyard, but like an industrial assembly line. Overhead cranes, railroad tracks, and vast prefabrication areas replaced gantry cranes and sequential building ways. And the workers, ordinary Americans thrust into extraordinary roles, were about to rewrite what was possible in shipbuilding, and perhaps, in human potential itself. The revolution in shipbuilding began not in the docks, but in the quiet offices of Todd Shipyards in New York. Henry Kaiser, a man who had never touched a ship, and his engineers scrutinized traditional shipbuilding procedures, quickly realizing that conventional methods could never meet the urgent demands of wartime production. Every step of a ship's construction, from laying the keel to installing the engine, took months in established yards. The Allied supply lines, stretched thin across the Atlantic, could not wait. Every day lost meant cargo sinking to the ocean floor under the relentless attacks of German U-boats. Kaiser's chief engineer, Clay Bedford, returned from Detroit with a vision that seemed absurd to the old maritime guard. He had studied Ford's assembly line, watching automobiles take shape as workers installed prefabricated components in a choreographed rhythm. If cars can be built this way, Bedford argued, so can ships. For traditional shipbuilders, the notion was sacrilege. Ships were not machines, they were living, breathing vessels that demanded craftsmanship honed over generations. Yet Kaiser saw an opportunity where others saw heresy. The first shock came with Kaiser's proposal to eliminate riveting entirely. Rivets, heated metal pins hammered through overlapping steel plates, had joined ships for centuries. Each Liberty ship conventionally required nearly 1 million rivets, with skilled crews installing barely 100 per day. Kaiser proposed electric arc welding, a technique he had mastered while building pipelines across the West. The maritime establishment was stunned. Could a hull welded in this way withstand the ocean's fury? Vice Admiral Emory Land, chairman of the United States Maritime Commission, examined the proposal with deep skepticism. Welding has never been proven reliable for hull construction at this scale, his private correspondence warned. The British Navy forbids welding on warship hulls. We would be betting America's supply lines on untested technology. Yet desperation left little room for doubt. Allied shipping losses were catastrophic. In 1941 alone, approximately 3.6 million tons sank, leaving Britain on the brink of starvation. Traditional shipyards, with their laborious 230-day construction schedules, could not keep pace. Approval of Kaiser's contract was not born of confidence, but of necessity. Once the contract was secured, the real work began. Richmond, California, a flat, muddy expanse of land, would become the site of an industrial experiment unlike any other. Instead of massive gantry cranes and long sequential building ways, Kaiser envisioned a facility more like an automobile assembly plant: vast open spaces for prefabrication, 7 parallel building ways, railroad tracks crisscrossing the yard, and cranes capable of lifting entire ship sections weighing hundreds of tons. Traditional engineers looked at the blueprints and scoffed. John Riley of Bethlehem Steel, a 30-year veteran, noted that Kaiser had violated every principle of shipyard efficiency he had ever learned. Yet, as he toured the partially completed yard in May 1941, Riley could not deny the genius behind it. Prefabrication areas were enormous, crane capacity absurdly high, building ways short, but the layout was perfectly suited for rapid assembly. The stage was set. The revolution would not happen overnight, nor in secrecy. It would unfold in full view of skeptics, journalists, and the world, proving that industrial innovation, when applied boldly, could turn ordinary men and women into architects of unprecedented achievement. Kaiser was about to show that speed, simplicity, and human coordination could do what centuries of tradition had declared impossible. The Richmond shipyard rose from mudflats in early 1941 like a vision that defied conventional engineering. Where traditional shipyards relied on massive gantry cranes and long building ways, Kaiser's design resembled an automobile assembly plant. 7 parallel building ways stretched across the yard, each flanked by open areas where prefabricated sections could be assembled. Railroad tracks crisscrossed the facility, designed to move steel sections weighing up to 150 tons. Overhead cranes, towering and precise, stood every 100 feet, ready to lift massive ship components into place. Experienced naval engineers looked upon the site with disbelief. John Riley, chief naval architect at Bethlehem Steel, visited in May 1941 and filed a confidential report. His words captured both his skepticism and grudging respect. "Kaiser has violated every principle of efficient shipyard layout I have learned in 3 decades. Prefabrication areas are too large, crane capacity absurdly excessive, building ways too short. Yet the facility is designed perfectly for what he claims: rapid assembly of prefabricated sections." Kaiser's genius lay in thinking differently. He treated shipbuilding not as a centuries-old craft, but as a manufacturing problem, one that could be solved with logic, organization, and parallel production. Instead of waiting for a hull to be completed before adding the engine, he envisioned entire sections, bow, stern, engine room, and deckhouses, being built simultaneously across the yard. When ready, cranes would lift and join them, a single operation replacing months of painstaking work. But a yard alone does not make a revolution, it requires people. Kaiser advertised nationwide, offering wages 20% above standard industrial rates and promising training to anyone willing to work. Secretaries, farmers, housewives, and laborers answered the call. By October 1941, Richmond employed over 10,000 workers, fewer than 200 with any prior maritime experience. Apprenticeships lasting years were replaced by focused, 2-week courses teaching specific welding tasks. Workers did not need to master everything, only the precise task they would repeat hundreds of times, from welding a vertical bulkhead seam to a horizontal deck plate. The transformation was immediate. Conventional shipyards, relying on sequential construction and generational expertise, could not match the pace. The first Liberty ship at Richmond took 197 days. By ship number 10, construction required only 97. Workers gained confidence and speed, and the statistical proof of prefabrication's power became undeniable. Kaiser's yard was more than a factory, it was a statement. It challenged centuries of tradition, proving that speed, coordination, and innovation could triumph over experience alone. Each crane lift, each completed section, each trained worker represented a calculated defiance of the old maritime establishment. By mid-1942, Richmond was completing ships in 70 days on average, astounding observers and sending shockwaves through traditional shipbuilding circles. As the hulls of Liberty's ships began to rise, one could see the future of industrial production taking shape in steel and sweat. Kaiser's vision was no longer theory, it was reality, and it promised to change the way the world thought about manufacturing forever. In the mud and chaos of Richmond, California, a revolution was underway. The arrival of workers at Richmond was nothing short of revolutionary. Kaiser's vision demanded more than cranes and prefabricated sections, it required ordinary people to perform extraordinary tasks, and fast. Secretaries from Los Angeles, farmers from Nebraska, housewives from San Francisco, and laborers from the railroads all answered the call. Few had ever seen a ship, let alone welded steel. Yet in these untested hands lay the potential to rewrite history. Kaiser's team of instructors, specialists in focused welding techniques, taught workers specific, repeatable tasks. Traditional shipbuilding relied on years of apprenticeship to create versatile craftsmen. Richmond's approach was the opposite: precision and repetition. A worker might spend 2 weeks learning only how to weld a vertical bulkhead seam. Another, how to secure deck plates. Complexity was broken down into manageable pieces. The result was astonishing. Within days, workers who had never held a welding torch were producing output comparable to veterans of the craft. The transformation was immediate and visible. In August 1941, the first groups arrived. By October, Richmond employed over 10,000, fewer than 200 with any prior maritime experience. The speed at which the workforce adapted was staggering. Kaiser's philosophy was simple: specialization over generalization, repetition over perfection, speed over tradition. Traditional shipbuilders watched in disbelief as construction times fell dramatically. The first Liberty ship required 197 days. Ship number 2 dropped to 169. By ship 5, 128 days. By spring 1942, the average had fallen to 70 days. The untrained workforce, guided by focused instruction and strict coordination, matched, or even surpassed, the pace of the most skilled crews in the country. The prefabrication approach magnified these gains. While one team welded a hull section, another assembled the engine, and yet another constructed the deckhouses. Massive cranes then lifted the completed sections into place, joining them in hours what would have taken weeks in traditional yards. Albert Wooding, Richmond's production supervisor, explained in 1943, "In traditional shipbuilding, you cannot install the engine until the engine room is built. Here, one crew welds the hull, another assembles the engine. When both are ready, we drop it into place. Weeks become hours." But speed alone was not enough. Kaiser's workforce included women, African Americans, and immigrants, breaking conventions of a segregated industry. Women, over 40,000 at peak production, operated cranes, welders, and fitters. African American workers filled skilled positions previously denied to them. These were not mere laborers, they were pioneers, proving that talent was not inherited, it was trained. The transformation extended beyond efficiency. It challenged assumptions about who could work in industrial America, what was possible in shipbuilding, and how innovation could upend tradition. Each completed hull became a symbol of what ordinary people could achieve when guided, trained, and organized to act in unison. By late 1942, Richmond's yard was more than a shipbuilding facility, it was a factory of possibility. Its workers had learned to turn chaos into order, inexperience into skill, and steel into vessels capable of sustaining an entire war effort. The revolution was no longer theoretical. It was alive, welding sparks flying under the California sun, shaping the future of industrial production. November 1942 brought the ultimate test of Kaiser's revolution. Richmond Yard No. 2 was about to attempt the impossible, constructing a complete Liberty ship in under 10 days, cutting the Oregon Shipyards record in half. The vessel chosen for this audacious endeavor would be named the SS Robert E. Peary, after the Arctic explorer whose spirit of daring mirrored the challenge at hand. The idea began with a casual remark from Vice Admiral Emery Land during an inspection. Noting the yard's progress, he commented that, while construction had improved remarkably, speed still lagged behind other mass production industries. Clay Bedford, Richmond's chief engineer, overheard the comment and took it as a challenge. He proposed a full-scale record attempt, promising it would not disrupt regular production schedules. Land, skeptical but intrigued, reluctantly approved. At 1:01 a.m. on Sunday, November 8, over 1,000 workers took their positions along the building ways. The prefabrication strategy had been meticulously planned. Every bow section, stern assembly, deckhouse, and engine module was completed, inspected, and staged before the keel was even laid. Massive cranes waited, engines were pre-tested, and every bolt and weld had a designated crew. Precision, coordination, and timing would determine whether history would remember this as triumph or catastrophe. Construction began with the keel. Within hours, the prefabricated bow, stern, and midship sections were lifted and aligned by cranes, welded into place with almost surgical efficiency. Workers rotated in shifts, maintaining 24-hour production schedules. The engine, a 140-ton triple-expansion steam power plant, was already mounted on its foundation and tested, ready to be slotted into position with a single lift. Where traditional shipbuilding required weeks to install such machinery, Richmond's crews completed it in hours. Observers, journalists, and officials watched with a mixture of awe and disbelief. The sight of ordinary Americans, housewives, secretaries, farmers, working alongside skilled welders to assemble a fully operational cargo ship at this speed was unprecedented. Sparks flew, steel groaned, and the rhythm of the yard became almost hypnotic. Every task, no matter how complex, had been broken into simple, repeatable actions, each perfected through weeks of specialized training. By the fourth day, the hull was complete. Engine installed. Deckhouses in place. Cargo hold secured. Steering gear mounted. Every component was operational. At 3:30 p.m. on Thursday, November 12, just 4 days, 15 hours, and 29 minutes after the keel was laid, the SS Robert E. Peary slid down the launching rails into San Francisco Bay. The crowd erupted. Maritime officials, military officers, journalists, and competing shipyard owners had come expecting failure or compromise. Instead, they witnessed a fully operational vessel, ready for service with only minor fitting-out remaining. Vice Admiral Land, present for the launch, captured the magnitude of the moment. 6 months ago, I would have called this impossible. Henry Kaiser has made traditional wisdom obsolete. This is a turning point for American shipbuilding. The successful launch was more than a record, it was proof. Prefabrication, welding, and the power of organized, trained labor could achieve what decades of tradition claimed impossible. The Robert E. Peary became the emblem of a new industrial era, where ordinary people, guided by innovation and necessity, could accomplish the extraordinary. The launch of the SS Robert E. Peary was more than a single achievement, it ignited a fervor across all of Kaiser's shipyards. Richmond Yard No. 2 had proven that rapid construction was not just possible but repeatable, and the results reverberated through California, Oregon, and Washington. The once quiet industrial landscape became a theater of speed, skill, and relentless ambition. Competition, though informal, fueled the revolution. Kaiser's son, Edgar, oversaw the Oregon Shipbuilding Corporation, while Clay Bedford managed Richmond. Both men, ambitious and determined, began measuring progress in days instead of months. News of record-breaking builds became a public spectacle. Newspapers reported ship launches like sports scores. Richmond beat Portland by hours, Portland reclaimed the title by minutes. When Oregon's Joseph N. Teal was built in just 10 days in September 1942, Richmond responded with new methods and higher coordination. The race pushed workers to heights that previously seemed unimaginable. Parallel production became the core of this industrial sprint. While one crew welded the bow, another assembled the engine, and yet another completed the deckhouses. Massive cranes lifted and positioned fully constructed sections, slashing construction time from weeks to mere hours. Every worker had a clear role, each task refined through repetitive practice. Where traditional yards demanded broad craftsmanship, Kaiser's facilities demanded precision, specialization, and relentless teamwork. The workforce itself had become a force of change. Tens of thousands of untrained workers were now highly skilled in their narrow tasks. Women comprised a remarkable portion of the labor pool, over 40,000 at peak production, operating cranes, welding, and fitting components. African American workers filled skilled positions, challenging conventions of segregation and demonstrating that talent could thrive under opportunity and training. Ordinary people had become masters of industrial coordination. The psychological impact on the maritime establishment was profound. Engineers from traditional shipyards traveled to Richmond, curious and skeptical, only to leave in awe. The speed, efficiency, and organization shattered long-held assumptions. Where centuries of craft had relied on generational expertise, Kaiser's approach relied on structure, planning, and the disciplined repetition of specialized tasks. By mid-1943, the effect was undeniable. Liberty ships were being completed in an average of 42 days across all Kaiser yards. The United States was launching 3 ships daily, outpacing German submarine attacks. Vice Admiral Howard Vickery, once a staunch skeptic of simplified drawings and prefabrication, acknowledged the power of results over tradition. Perfection is the enemy of sufficient. These ships are not beautiful, but they are adequate, and adequate ships delivered faster than perfect ships under construction. Kaiser's 7 yards produced a combined 1,490 ships, nearly 27% of all American wartime merchant shipping. The competition between Richmond and Portland, initially a spectacle, became a model of industrial motivation. Workers internalized the expectation that extraordinary speed was not only possible but required. Each record broken reinforced a culture of excellence, discipline, and relentless innovation. The race across the yards proved that industrial transformation was not merely about tools or technology, it was about people, organization, and belief. The Liberty Ship program was no longer an experiment. It was a revolution in motion, showing the world that ordinary Americans, guided by unprecedented systems, could achieve the extraordinary. By 1943, the Liberty Ship program had become more than a technical marvel, it was a social revolution. Kaiser's shipyards, from Richmond to Portland, were reshaping not only the speed of construction but the very nature of the American workforce. Tens of thousands of ordinary people, previously excluded from industrial opportunity, were now the backbone of a system that delivered ships faster than any enemy could sink them. Women were the most visible symbol of this transformation. At Richmond, over 27% of the production workforce was female by mid-1944. They operated cranes, handled welding torches, assembled deckhouses, and supervised sections of production. Their presence challenged centuries of gender norms, demonstrating that skill was learned, not inherited. African American workers, who historically faced exclusion from skilled positions, were employed as welders, fitters, and even crane operators. Integration was not a gesture, it was necessity. The war demanded results, and talent was the currency. The scale of the workforce was staggering. At peak production, Kaiser's 7 yards employed nearly 196,000 people. Workers rotated in shifts around the clock, executing tasks broken into precise, repeatable steps. This division of labor, paired with prefabrication, meant that even the most complex ships could be assembled in weeks instead of months. Specialized training programs, some as short as 10 days, produced competent workers who could immediately contribute to construction. Apprenticeships lasting years were replaced by task mastery, efficiency, and confidence. Yet the transformation extended beyond productivity. Kaiser understood that morale and community mattered. While traditional shipyards observed holidays with minimal acknowledgement, Richmond maintained production schedules while providing celebrations for workers. Christmas 1943 featured free dinners of turkey and ham, carolers from local churches, and performances by the Richmond Municipal Band. Kaiser himself visited the yards, shaking hands and thanking workers personally. These gestures reinforced loyalty, motivation, and a sense of shared purpose. The social impact rippled beyond the shipyard gates. Cities like Richmond and Vanport, Oregon, swelled with workers and their families. Richmond's population grew from 23,000 in 1940 to over 100,000 by 1943. Entire communities were built around the yards, creating temporary boom towns fueled by industry, opportunity, and necessity. These workers carried the skills, confidence, and experience gained into the post-war world, opening doors that had previously been closed. Kaiser's methods demonstrated that industrial innovation was not only a matter of machines and blueprints, it was a human endeavor. By proving that ordinary Americans could master highly complex tasks when given training, organization, and belief, he challenged the deeply entrenched notions of skill, labor, and hierarchy. Liberty Ship workers became living proof that potential could be unlocked under the right conditions. In the steel and sparks of Richmond, Portland, and across the Pacific Northwest, the war effort had catalyzed a transformation not only in industry but in society itself. The Liberty Ship program was more than a logistical achievement, it was a statement that inclusivity, training, and belief in ordinary people could achieve extraordinary outcomes. Kaiser had turned the workforce itself into a weapon, one as decisive as any naval fleet. The impact of Kaiser's Liberty Ship program extended far beyond the Pacific coast and the immediate needs of World War II. By demonstrating that ships could be built in weeks rather than months, he had rewritten the rules of industrial production. Prefabrication, parallel assembly, and specialized task training became principles not just of shipbuilding but of manufacturing worldwide. Post-war observers were astonished at how quickly American shipyards could transition from emergency production to peacetime applications. The techniques pioneered at Richmond, Portland, and other Kaiser yards became the blueprint for modern ship construction. Prefabricated sections, welded rather than riveted, were now standard practice in yards across the globe. Countries rebuilding after wartime devastation, Japan, South Korea, and later even Europe, looked to Richmond as a model. The massive shipbuilding facilities in Ulsan, South Korea, and Nagasaki, Japan, were direct descendants of Kaiser's revolutionary methods. The human lessons were equally profound. Workers trained in highly specialized tasks during the war carried their skills into civilian industry. Welding, fitting, and assembly techniques developed under pressure were applied to bridges, pipelines, housing, and industrial facilities. The emphasis on rapid training and task mastery reshaped vocational education, proving that focused, intensive instruction could yield competency far faster than traditional apprenticeships. American industry as a whole took notice. Kaiser's methods showed that perceived limitations, labor skill, industrial capacity, even technological inexperience, could be overcome with careful organization, prefabrication, and modular thinking. Companies across manufacturing sectors began to implement production lines for everything from automobiles to airplanes, translating the principles of parallel production into diverse industrial contexts. The Liberty Ship program also left a lasting imprint on workplace culture. Kaiser's inclusive approach, employing women, African Americans, and unskilled workers, challenged entrenched social norms. Industrial leaders observed that diversity, when paired with training and clear roles, enhanced productivity rather than hindering it. These lessons informed post-war corporate policies, labor integration, and management practices for decades to come. Beyond industry, Kaiser's program influenced healthcare and urban planning. To support tens of thousands of workers, Kaiser partnered with Dr. Sidney Garfield to provide prepaid healthcare programs. This initiative evolved into Kaiser Permanente, one of America's largest healthcare organizations, proving that innovative industrial management could extend into social infrastructure. Cities like Richmond and Vanport, built to house the workforce, became laboratories in urban development, demonstrating the economic and social power of concentrated industrial investment. Yet perhaps the most enduring legacy was psychological. By showing that ordinary people, organized efficiently, could achieve what experts deemed impossible, Kaiser shattered the myth that progress required only tradition, expertise, or inherited skill. Industries learned that innovation often comes from those unbound by convention, willing to question long-held assumptions, and bold enough to implement radical ideas. The Liberty ships themselves, 2,710 vessels launched between 1941 and 1945, remained the ultimate testament. Many lasted decades, proving that speed and efficiency did not compromise utility. They were physical proof that industrial revolutions could happen in months, not centuries, when necessity, vision, and human potential aligned. In the sparks of Richmond's welding torches and the hum of its cranes, the world saw more than ships taking shape. It saw a model for modern industry, a template for what could be achieved when ordinary people were trained, organized, and empowered to do the extraordinary. Kaiser had not only built ships, he had built a new understanding of possibility. By 1944, the Liberty ships were no longer experimental marvels, they were the lifeblood of Allied logistics. Across the Atlantic and Pacific Oceans, these vessels carried tanks, jeeps, ammunition, and food to sustain armies and populations under siege. Their presence demonstrated that industrial speed, once considered theoretical, had tangible strategic consequences. The mathematics of war were now dictated not only by battles fought on beaches and in skies, but by the relentless output of American shipyards. Despite their rapid construction, the ships proved remarkably durable. Designed initially for a 5-year emergency service life, many exceeded expectations, navigating storm-tossed seas, enemy fire, and long voyages without major structural failure. Though 3 Liberty ships suffered catastrophic brittle fractures, representing a mere 0.11% of production, lessons learned quickly led to improved welding techniques and stronger steel specifications. The remaining fleet, numbering over 2,500 operational vessels, carried cargo with extraordinary reliability. Strategically, the impact was immediate. German U-boats and surface raiders, initially confident they could outpace American production, faced an industrial tidal wave. Convoys lost vessels, but replacements arrived faster than the Axis could sink them. Admiral Chester Nimitz, commander of the Pacific Fleet, reflected on the logistical advantage in his memoir, "We fought across 5,000 miles of Pacific Ocean, supplied by ships built faster than the enemy could sink them. Japan assumed our industrial capacity was finite, they underestimated Henry Kaiser." The Liberty ship's effectiveness also challenged long-held assumptions about craftsmanship and quality. Traditional maritime experts doubted that welded, prefabricated ships could survive wartime rigors. Yet the statistics were irrefutable. Of 2,710 Liberty ships built, only about 200 were lost to enemy action, a loss rate of just 7.4%. Ships could be adequate rather than perfect, and yet still fulfill their purpose decisively. Adequacy multiplied by thousands proved far more powerful than perfection multiplied by dozens. The operational success of Liberty's ships extended beyond their durability. Their rapid construction allowed the Allies to maintain supply lines across multiple theaters simultaneously. Every convoy launched with these ships represented a logistical triumph, a demonstration of how human organization, standardized production, and innovative industrial thinking could influence the course of war. They were not just vessels, they were weapons in a different sense, tools of strategic endurance. Beyond their military role, the ships became symbols of American ingenuity and industrial determination. To the Allied nations, the fleet represented the potential of a nation mobilized and organized to meet extraordinary challenges. British observers, once skeptical of American shipbuilding, documented astonishment at the volume and speed of production. Commander Joseph Kenworthy of the Royal Navy noted in official reports, "The Americans build adequate ships in weeks. Adequate multiplied by thousands defeats perfection multiplied by dozens." As waves lapped against their hulls, Liberty ships carried more than cargo, they carried proof that human potential, when organized and empowered, could achieve the extraordinary. Each voyage reinforced the lesson learned at Richmond and Portland: ordinary people, trained, coordinated, and motivated, could reshape the world through sheer industriousness. When the guns fell silent in 1945 and the last Liberty ship was delivered, the world had changed. Henry Kaiser had done more than build ships, he had rewritten the rules of industry, labor, and possibility. The SS Albert Bow, the final Liberty ship, slid into the water on October 30, 1945. For many, the end of production marked the closure of a monumental wartime effort. For Kaiser and his workforce, it was a demonstration that industrial revolutions could be deliberate, measured, and transformative. Kaiser's methods did not vanish with the war. Prefabrication, welding, and parallel assembly became global standards in shipbuilding. Countries rebuilding their fleets studied Richmond's blueprints, replicated its facilities, and adopted its systems. Japan and South Korea, once devastated by conflict, transformed their maritime industries by following the model established in California and Oregon. The principles that had accelerated Liberty ship construction also influenced bridges, pipelines, housing, and even aerospace manufacturing. Kaiser had shown that systems mattered as much as steel. The human legacy was equally profound. Tens of thousands of workers, women, minorities, and untrained laborers, emerged from the shipyards with skills, confidence, and opportunity. Many carried those experiences into post-war industry, commerce, and education, forever altering social norms. The integration, training, and empowerment demonstrated in wartime shipyards proved that efficiency and inclusivity were not mutually exclusive. Ordinary Americans had achieved the extraordinary, and the world would take notice for decades. Kaiser's wartime vision also gave rise to innovations outside the shipyard. To care for his massive workforce, he partnered with Dr. Sidney Garfield to develop prepaid healthcare programs, which evolved into Kaiser Permanente, one of the nation's largest healthcare systems. In Richmond, Vanport, and other industrial boom towns, urban planning, housing, and community infrastructure advanced in tandem with production, proving that industry could shape society responsibly. Perhaps the most enduring proof of the Liberty ship program's success lies in the ships themselves. Though most were eventually scrapped or sank, a few survive as museum ships, enduring symbols of industrial triumph. The SS John W. Brown sails today in Baltimore, a testament to durability after 8 decades. The SS Jeremiah O'Brien, preserved in San Francisco, retraced its voyage to Normandy 50 years after D-Day, demonstrating the longevity and reliability of a vessel designed in wartime for a mere 5 years. Kaiser's ultimate achievement was neither the number of ships built nor the speed record set, it was the transformation of what industries believed possible. The Robert E. Peary, built in under 5 days, became proof that conventional wisdom could be challenged, that ordinary workers could accomplish extraordinary feats, and that industrial and human potential were far greater than anyone had imagined. From Richmond to Portland, from the steel mills of California to the shipyards of Korea and Japan, Kaiser's influence endured. The Liberty ships carried more than cargo across oceans, they carried the demonstration that innovation, organization, and belief in people could turn the impossible into reality. In every modern shipyard, in every manufacturing facility that uses prefabrication, in every fast-paced training program, the spirit of Henry Kaiser's revolution lives on. The story of Liberty ships stands as a reminder. Progress often comes from those unbound by tradition, willing to reimagine the rules, and bold enough to organize ordinary people to achieve extraordinary results. Kaiser proved that the spark of human ingenuity, when paired with necessity and opportunity, can change the world.